telescope is a device like this one that allows us to observe distant objects. So we can say that the telescope is an extension of the human eye. Okay? The human eye is very limited. The human eye cannot perceive very far objects or distant objects. Now, the telescope allows us to observe distant objects. So, pretty much like an extension of the human eye. Okay, the first telescope was made by Hans Lippershey, not Galileo. It was Hans Lippershey that came up with the first telescope. Okay, then Galileo got heard of this new device, so he made one for himself. And it was Galileo that pointed the telescope towards the sky. And because of his observations using the telescope, Galileo was the first to observe the moons of Jupiter, the 4 moons of Jupiter. Galileo also was the first to observe the craters of the moon, the phases of Venus. And because of that, his observations of Venus, that gave him the evidence to support the Copernican model of the solar system. Okay. A telescope works by collecting light from the distant object. Now, in this telescope, there is a mirror at the end of the telescope tube. This is a primary mirror. Now, that primary mirror collects the light from the distant object and brings it into a focal point somewhere here. Then, there is a flat mirror here that reflects the light onto this eyepiece. So the eyepiece further magnifies the initial image, producing the final magnified image. Okay. In the case of the telescope made by Galileo, you have lenses. Okay. The telescope made by Lippershey and Galileo, we call it the refracting telescope that uses lenses. This telescope is called the reflecting telescope. The design was made by Isaac Newton. Okay. Okay, let me give you now a guided tour of the basic parts of this telescope. So this is the telescope tube. Right, this telescope is a reflecting telescope. Reflecting because this telescope uses mirrors to produce a magnified image. So inside the telescope tube is the primary mirror. You can see the primary mirror below the telescope tube. The primary mirror is a concave or spherical mirror. See that? And near the top of the telescope tube is a secondary flat mirror. There. So the primary mirror collects the light from the distant object and it brings it into a focal point. Then the flat mirror reflects the initial image onto this eyepiece. Okay, that's your eyepiece. This design was made by Isaac Newton. So this is what we call a Newtonian reflecting telescope. Alright, so we have here the focusing knob and we have here the finder scope. The finder scope allows you to locate your target object. Okay, then below here we have 2 knobs. This is the declination knob and this knob right here is the right ascension knob. Then we have here the counterweights, so it allows you to balance your telescope. And you have here the mount and tripod. The mount is called an equatorial mount. Anyway, we will explain later how the equatorial mount works. Okay, so those are the basic parts of this telescope, reflecting telescope. Okay, so this type of telescope is a refracting telescope. So a refracting telescope uses lenses to produce a magnified image of the distant object. So there are two major lenses here. We have here the objective lens. Okay, the objective lens collects the light from the distant object, and at the opposite end of the telescope tube is the eyepiece lens. Okay, so this telescope is similar to the one made by Hans Lippershey, by Galileo, and by Johannes Kepler. So, and this telescope is mounted on an altazimuth mount or altazimuthal mount. So in this type of mount, there are two movements. So we have the left and right movement, like so, and the up and down movement. So this type of mount is called an altazimuth or altazimuthal mount. Okay, so advantages of this telescope. This telescope is rigid, sturdy. You don't need to align the lenses, and it's quite good. The only disadvantage of this type of telescope is that this telescope produces color fringes, or the refracting telescope suffers from what we call chromatic aberration. But again, modern refracting telescopes now have correcting lenses that eliminates chromatic aberration or minimizes chromatic aberration. Alright, so again we have here the finder scope. So this finder scope allows you to locate your target. Okay, so this is a refracting telescope. So this is what we call a reflecting telescope. Okay, by the name itself, reflecting, this telescope uses mirrors to capture the light of a distant object. This telescope was designed by no other than Sir Isaac Newton himself. Okay, so inside the telescope tube is a concave mirror. So as you can see here, alright, so inside there is a concave mirror that collects the light, let's say, of a distant object, say the moon or a star or a planet. Then the collected light is bounced off a secondary mirror. There's a secondary mirror near the top of the telescope tube, and it is reflected onto this eyepiece. So if you look at the eyepiece, the image is magnified. Okay, what we have here also is a finder scope that allows you to locate your target. The telescope is mounted in an equatorial mount. So the equatorial mount is polar aligned, meaning that it is pointing at the North Star. But anyway, I will explain further the use of the equatorial mount. Advantages of this reflecting telescope: well, it eliminates color fringes or chromatic aberration, and it is cheaper than the refracting telescope, which I will explain later. Okay, this type of telescope is what we call a catadioptric telescope. Okay, catadioptric, that means that it is a combination of both refractive and reflective elements. Now, in front of the telescope is a correcting lens. This correcting lens minimizes or corrects any color fringes or chromatic aberration. Then at the back of the telescope is the primary mirror. Then there's a secondary flat mirror. So it's similar to the Newtonian telescope, but the only difference is that in front of this telescope is a correcting lens. So it is a combination of both refractive and reflective elements. So we call this a catadioptric telescope. Okay, so let us now study the so-called equatorial mount. So this reflecting telescope is mounted in what we call an equatorial mount. This is quite different from the altazimuthal mount of the refracting telescope, the one that I mentioned a while ago. So if you will notice, this part of the mount must be pointed at the polar star. The polar star is Polaris. So we must look at the north. We must find first north using this digital compass. So if we find north, then this part of the equatorial mount should be pointed north, and this part is tilted at about 15 degrees from the horizontal. In fact, the North Star or Polaris is 15 degrees above the horizon, or 14.2 something degrees above the horizon. Okay, now you will notice that in the equatorial mount there are two knobs here. This is what we call the declination knob, and this is the right ascension knob. So if your mount is polar aligned, and if you were able to find your target, all you need to adjust is the right ascension knob. Okay, right ascension, because if you will use your body, your front here is north, the back is south, your right hand here is east, and the sun, the moon, and the planets, they all rise eastward. So right ascension. So the moon and the planets, they ascend eastward. So right ascension. So if everything is polar aligned, then all you need to adjust is the right ascension knob. And this mount is very good for astrophotography. And if you have a motorized thing, you can attach it here and it will all be automatic. So that's the advantage of the equatorial mount, in contrast to the altazimutal mount. Okay, so I hope that you have learned something about telescopes. Thank you for listening. This is Jun Cajigal. This is Astronomy at Home, and be safe.